All right, so it's a great pleasure to have Monica Costa from University of Bristol and IFS talking about measuring and comparing assortativeness. Thanks for having you. You have 1.5 hours.
Well, thank you very much, Hans-Martin, for inviting me, and good morning to all. I'm sorry that I cannot join you in person, but I hope this is useful anyway, and do ask questions as I go along. Although I'm not in Zurich, but I can try to join after. I'm afraid. Okay, so I am Monica Costa, as Hans-Martin introduced, and in this session, I'll be talking about my recent work with Pierre-André Capelli and Costa here, which is on measuring and comparing assortativeness in marriage markets. So it's not going to be really about life cycle. It's only going to be about one specific period of the life cycle. Now, the paper that I'm going to talk about is actually a set of a couple of papers, but I'm going to focus mostly on one of them. It's part of a wider research agenda that aims to shed light on the determinants of family inequality and their consequences for the well-being of families and of children. And so essentially we look at how these inequalities are formed over the life cycle, taking into account the various stages of life. And in particular for today, I'm going to talk about this one specific period, which is marriage. So here, as I told you, it's going to be about this, very small part of this work, and the focus is going to be really on trying to determine whether the preferences for the characteristics of the spouses are changing in ways that promote economic inequality, and to do so, I will develop the tools to be able to disentangle these changes in preferences, or supposedly changes in preferences, from changes in the distribution of the characteristics of spouses that are economically valuable. So this is exactly what I'm going to discuss today. So to start motivating our interest in this topic, I just noticed that inequality in family incomes has been increasing almost everywhere. To be fair, this data here is already not the most up to date. It goes up to 2010 in most countries, and it's just OECD data that is similarly collected for various countries. And what this graph shows is the changes in the Gini coefficient from the mid-80s to about 2010 in a set of countries. And what you can see there on the left is that almost everywhere there is a non-negligible increase in this index of inequality, while there are a few countries, actually mostly in Europe, where and in a very small set of countries that might actually have dropped. But for countries like the UK and the US, which are in particular the two countries that we study in this couple of studies, the inequalities have increased, and they've increased quite substantially across families. So now this phenomena has raised attention to the study of sorting in the marriage market. And this is because of its potential important role in driving inequalities between families. So sorting, what I mean by sorting in marriage, refers to the extent to which like marries like. So it is likely that that preference for someone like you can be driven by the benefits of marrying someone specifically, as compared to marrying others or remaining single, which is the alternative. Now, if traits like educational skills or labor market productivity matter for sorting in marriage, then sorting may magnify inequalities that pre-exist the marital stage in life. And more broadly, sorting may have consequences for family formation and the intergenerational transmission of human capital, for instance, if it happens along dimensions such as education. And so to understand how these changes happen and the long-term consequences it may have, studying the sorting in marriage is a key component to study inequality and social mobility more broadly. So, for example, to the extent that men and women, human capital, are complementary in the production of children, so in raising children and in determining their abilities, an increase in sorting in marriage will likely lead to an increase in inequality in the human capital of future generations. On the other hand, it is precisely these complementaries and the well-documented increase in the returns to human capital that have happened over the more or less the same period that may underlie an increase in assortativeness that we see in marriage. So, you know, it not only leads to more inequality, it is this inequality and this enhanced role of human capital in producing economic well-being, but also inequality that leads to more inequality in marriage earlier on in life as people anticipate the gains from marrying up. So in this project, I'm sorry if you can hear my cat meowing, but I got too much. So this project is going to investigate these issues. We will be focusing on marital sorting by education, which, by the way, is a well-established trait among which sorting actually is very strong. And we will be asking the following questions. First, whether assortativeness in marriage by education increased, and in particular, I'm going to focus in the case of the US. I'll show you that it did. And we have, as I told you, a parallel set of results for the UK, which look similar to those that I'm going to show you for the US. So where we also find that there is an increase in assortativeness in marriage. Second, we are going to ask the counterfactual question of how would marital patterns look like today if assortativeness had not changed. Now, this question is key to establish the impact of changes in assortativeness on changes in inequality in family income, which is the third question we ask, but I'm not going to address this in this talk. However, the companion papers that actually I offer a link at the end of these slides too, they do discuss this and how to go from one to the other in terms of establishing results. So to address these questions, we first need to establish a few things. First, we start by defining exactly what we mean by assortativeness, and we need also to define not only what we mean by assortativeness, but also what we mean by changes in assortativeness. And you'll see that while the first is very easy, the second actually is quite, it can be a bit tricky. Then we need to establish how to measure these concepts, and I'm going to propose a way. And then we need to reflect on how to translate changes in assortativeness that we have identified into marital sorting patterns. So that's sort of what I'm going to do today as we move along. So as I mentioned, it turns out that actually establishing whether or not some marriage market is assortative is actually not that difficult. But by comparison, comparing assortativeness in two different markets is actually quite challenging. And you will see that we only have a partial response to this problem. Now, the key problem is how to separate differences in assortativeness, which arise from differences in the structure of gains from marriage. So those who are driven by the value of marriage, by the sort of the structure of the marital problem, from those differences or changes that are mechanical and that arise from differences in the distribution of sorting traits and characteristics. So for instance, suppose we are studying sorting in marriage by education in, across two cohorts. So we are comparing the two cohorts. And we know that the underlying distributions of education changes also across the two cohorts. If in particular, the later cohort is more educated overall than the earlier one, then we would expect to find more highly educated spouses matching each other in the later cohort than we have in the earlier cohort, simply because there are more of them. So this means that, finding more marriages between high educated spouses could be simply a mechanical effect of there being more highly educated people in the population to choose from, and not indicate a change in the structures of gains from marriage, which indicates that, the value of these traits are now more valuable for some reasons that can be then determined later on in life. So if there is genuine increase in assortativeness, then it must be driven by changes in that value, the value of marrying someone like me as compared with marrying someone else, which is different. And establishing this, what part of the changes in sorting patterns comes from this, part, which is the value of marriage, as you now may sense, it's going to be quite difficult without a reference to a model. Okay, so how did assortativeness in marriage change in the US, and did it actually increase in the US? What do we know from the past literature? There are quite a few studies, both in economics and in other social sciences like demography and sociology, which focus on whether assortativeness in marriage by traits that are linked to income have changed. A majority of these studies has suggested that assortativeness by education increased over the past half century or so. But these results are confounded by dramatic changes in the distribution of education that also happened over the same period, and that I'm going to show you. And these have led other studies to find either drops actually in assortativeness in parts of the distribution, or drops in assortativeness in parts of the period. Here we argue that the contradictory results are partly a consequence of the failure to understand that empirical changes conflict changes in the distribution of the underlying traits and in the preferences for these traits in marriage, and result from the fact that, from this failure to understand that you actually need, more structure and a model to be able to design, that you can interpret. So let me show you, just to motivate a few, the figure which looks at trends in the proportion of homogamous couples. Homogamous couples are couples where the level of education of both spouses is the same. So like marrying like high educated college graduates, marrying college graduates, and so on. As I told you before, already, assortativeness in marriage looks into the odds of people marrying their likes. And so this graph here gives you an idea of how this evolved in the US. It shows essentially the probability of these homogamous couples, so couples with the same, where both spouses have the same level of education, where we consider 4 educational groups. And these are the 4 educational groups that we are going to consider for the rest of the talk when I give you sort of empirical results. And they are high school dropouts, high school graduates, people who have some college but not a college degree, and people who have a college degree or more, which is 4 years plus college. So to look at marriage, there are a few empirical choices that you have to make. First of all, people's marital status varies over the life cycle, and therefore you need to choose where to look at marriages. We are looking at people aged 35 to 44. This is a stage in life where the marital rates have stabilized, and so this is the population we are considering. And what we see in this, considering this population, what we see in this graph is that similar to actually what has been found in another study by Shen, which is a very recent study, the probability of homogamous marriages by education was actually dropping mildly in the earlier part of the period. And then it started to increase quite strongly from then onwards, which is going to reflect essentially the outcomes of those who were born, given the age range that we are considering, is the outcomes of those who were born in the 40s and later, that are going to be captured in this part here of the curve. Of course, the graph does not establish whether assortativeness increased, because what happened over the period was also a really pronounced increase in educational attainment, which we can see here in this graph. This happened actually for both men and women. What we see here is the proportion of individuals who have attained a certain level of education, again, from the same population. And what we can see in this solid blue line is that there is a marked drop in the size of the lowest educated group, who are the high school dropouts, and both among men and women. And that for women as well, there is also a drop from the early 80s onwards in the proportion of women who have finished education with as a high school graduate, which is the second bottom educational group. To compensate, the numbers of men and women with some college and college degrees have increased very sharply, and more so for women than it did for men. So what happened is that women who were initially less educated than men looked more and more like men as the periods sort of developed, as time evolved, and actually even overtook men towards the end of the period. So if the distribution of both sides of marriage markets, or the distribution of education, become more equal towards the end of the period, then again, there is more opportunity for positive sorting mechanically, just because there is, the two distributions are more aligned. So what we want to know here again is the extent to which these changes in the probability of marrying the alike are driven by these changes in the distributions of education, which make the two sides of the marker more alike, or whether over and above these, there is a role for changes in the body of education to be driving these shifts. Okay, so what am I going to do in the rest of this talk? Just to give you sort of a structure. First, I'm going to define assortativeness and changes in assortativeness, as I told you before. What I'm going to do here is to propose a minimum set of properties that a measure of assortativeness should satisfy to detect changes in assortativeness. In fact, as I discussed before, the fact that different studies give different responses to whether or not assortativeness has increased in the US is partly a consequence of the measures that they use to measure assortativeness being different, and some of them not actually fulfilling the minimum set of assumptions required for us to be to consider that they are going to reflect assortativeness. Then once I do this characterization, I can propose a measure of assortativeness that actually ticks the box, that is that fulfills that satisfies these conditions. You will see that this measure relates to the economic structure of the problem, so relates to the structural problem, the structural economic problem of matching, of choosing your spouse in a market. But it's a theoretical measure, so it does not per se have empirical use. So what I'll do is to develop the empirical counterpart using a framework that was first developed by Xu and Xiao. I show that this measure is based on very strong assumptions, that if we want to relax these assumptions, we can, and develop a set of new distribution-free concepts for measuring assortativeness. I will not discuss the other measures of assortativeness in this presentation, but there is some discussion in the papers if you are interested in looking through. But I'll show you some results of how assortativeness by education change in the US using both the index that I'm going to develop plus the distribution-free concept. And the index in particular is going to show results that are very similar to what other measures of assortativeness also show. And then we can use the structure of the problem that we identify when calculating these measures to quantify the role of changes in assortativeness on the marital patterns that we observe in the most recent cohorts as compared with the earlier cohorts.
There's another one which just came in, which says, can't changes in the distribution of education through time be partly driven by assortative matching? And so decomposing just mechanically for this change can be problematic. For example, women's schooling may increase due to better marriage opportunities.
Absolutely. Yes. So, of course, you know, I'm looking at marriage and saying that, you know, the value of marriage may change. The value of marriage by education may change. And that reflects changes that, you know, come from, you know, the rest of your life. The same way that this happens and you anticipate these gains and therefore change the assortativeness, these will also be reflected in the investments that you do pre-marriage. And so these changes in the education distribution may in part reflect the changes in the value of education that come through marriage. That's absolutely correct. What we are going to do here is that, you know, taking these changes in the distribution that nevertheless would lead, if we were thinking that the value of marriage by education did not change, to a certain change in the sorting matrix that we would observe. So even if there was no change in the value of education in marriage, but then the reinforcement of these you know, changes in the matrix, the sorting table would come through a change in the value of education in marriage. So that's what we are trying to disentangle. Yeah. I didn't hear the first question, Hans-Martin.
Yeah, basically I postponed it till after you were done with point one, but I think there was quite some overlap in the two questions directly. Otherwise, I asked this person who asked it to just alert me again if it's still unclear in 5 minutes.
Perfect. Okay, so let's start with defining what assortativeness in marriage and changes in the assortative marriage mean. Okay. To do so, let me introduce the setting that I'm going to use in this presentation. Okay, so we first consider a finite number of observed types. So individuals in each side of the market are characterized in particular by the type to which they belong. This is typical in the literature. In particular, here for this study, I'm going to focus on education. You can think of about other types or combination of types. But the key issue here is that the types are discrete. So there are a finite number of those types, whatever combination you want to use. So moreover, I will specifically be looking at sorting in a 2x2 matching matrix. Now, you may think that this is super restrictive. It does not mean, however, that I won't be able to look at larger sorting matrices. I will. And I already, actually, I told you that we are going to consider 4 educational groups when we do the empirical analysis. However, it is important to bear in mind that assortativeness is actually a local concept, in the sense that we can look at assortativeness between 2 groups and establish what, that it varies in one direction or the other. But it could happen that assortativeness between another 2 groups, one of which may be one of the first 2 groups, may vary in the opposite direction or not vary at all. So it's a little bit like a second derivative when you think of it, which may change sign. So it may be, may have one sign in one part of the function, a 2-dimensional function, and may have another sign in another part of a 2-dimensional function. So we will actually develop measures that allow for assortativeness to increase at one part of a sorting matrix while decreasing at another end. And to characterize how the market changed, you actually will have to look at the overall characterization of the entire matrix locally into its various bits. So to start with, I'm going to consider this 2x2 matrix, and then I'm building up on this 2x2 matrix to, to form the overall description of the entire changes in assortedness. Okay, so let me consider to simplify two educational groups, sort of, so that it's easier to discuss. Let's consider college and high school graduates, and I am considering this, table of marriage or marital sorting, which for the moment is going to be conditional on marriage. That is, I'm considering only individuals who decide to marry, so I'm removing the singles, but I'll be able to introduce as well the singles later on, and that's actually going to be simple, and so I postpone it. So the matching table that I'm considering is represented here in this slide, and I'm calling it the table M, N, R. Okay, so what are M, N, and R? M is the proportion of, so you see that, you've got men on the column and women on the row. We have got college and high school graduates on both sides of the market. And we've got M being the proportion of high educated men, so college graduates, and N being the proportion of high educated women, so college graduate women. And R is the proportion of high educated men marrying high educated women, so college marriages. These three numbers essentially characterize the entire sorting matrix that characterizes this particular section of the market. Okay. Okay, so we can now define what positive assortative matching, or PAM for short, means. The benchmark is random matching, and we define as positive assortative matching as more people concentrating on the May diagonal, so on college, high school marriages, then would have been implied by random matching. So this is simple. If we have PAM, so we have positive assortative matching, if R, that proportion of college graduates who marry college graduates, is larger than what will be implied by the random matching. What will be implied by the random matching is represented here by this table MN, which is a similar table to what we had, with the same marginals, that is, with the same distribution of education for men and for women in the market, but with different sorting patterns, where exactly the proportion of men college graduates marrying women college graduates is just the product of the number of college graduate men and college graduate women, so MN. So what we do have is that PAM is going to be defined here by this expression, which means that we've got positive assortative matching whenever we've got the concentration of college marriages being larger than what is implied by the random matching M times N. That is exactly the same as saying that the concentration of high school marriages that we observe empirically, which is this 1 minus N minus M plus R, is also larger than what will be implied by random matching. So what we do have is that the concentration of marriages in the main diagonal is larger than what would be implied by random matching. And that's when we say that there is positive assortative matching. And of course, if you have negative assortative matching, it would be exactly the opposite result that you have. Okay, so what about comparing assortative matching in two markets? Now, this is actually much more difficult. So when we have, say, two tables, M and R, as we had up to now, and another table, M prime, N prime, R prime, comparing the two is going to be difficult because it's not only R that varies, it's also the marginals M and N that are represented by M and N that vary. And so, what I'm going to do now, I'm going to concentrate on PAM from now onwards, leave the negative assortative matching, which is just very similar, and so we don't need to characterize the conditions for it as well. To start showing what the problems are, I'm going to consider two simple examples. I start with this first example. Actually, before I go into this, let me just warn you that these simple examples are not going to represent the entire set of possible comparisons. And as you will see, they will then be reflected in the fact that we don't have a set of conditions that are complete when we aim to characterize a measure of assortativeness that can tell us whether there is positive or assortative matching or not, and compare two markets. So what these examples are going to be used instead is to define a minimal set of conditions that the measures of assortativeness that we consider and rely on should satisfy for them to be able to detect changes in assortativeness when we compare two markets. But that's a minimum, not a complete set of conditions. Now, the first example is for two markets which have the same marginals. So in these two markets, the problem that the changes in the distribution of education may conflate changes in the value of marrying different individuals is not present because there is no change in the distribution of education between the two markets. So in this case, it's simple, and we can say that these two matrices, which now are MNR and MNR prime, so different proportion of individuals marry their likes, but the distribution of education is the same across the two populations. The first table is more assortative, positive assortative than the second table whenever R is larger than R prime, okay? Or which is the same whenever the proportion of high school graduates marrying high school graduates in the first table is larger than the corresponding value in the second table. The second example is that of perfect assortativeness. Any index or any measure that we want to rely on will have to be maximal when there is perfect assortativeness. And so if you have a market where there are the same number of college graduate women as men, so M and N are the same, and all of them match together, so all of them marry, so the table is essentially, the only positive values on the table are on the main diagonal, then that's any measure for that matrix should be maximal. So the assortativeness is maximal on that particular market. So as you can see, there are many other cases that these examples do not contemplate, do not describe. Okay, but what we do is then to use them to define the formal requirements that an index should satisfy, that a measure of assortativeness should satisfy if we are going to rely on it. So just as a bit of background, the usual practice in the literature is to define an index of assortativeness to measure assortativeness. So it's a one-dimensional measure that quantifies the degrees of assortativeness in a market, and that we use as well to compare markets. So let's call such an index I, capital I, which is a function of the measures in the market, M, N, and R. So we say that the market M and R is more assortative than M prime, N prime, R prime whenever the index for the first market is larger or equal, if it's not strict, than the index for the second market. We demand that that index satisfies these two conditions. The first is monotonicity. Whenever you've got two markets with the same M and N, the index should be increasing in the third argument R. And the second is the perfect assortative matching condition, which means that the matrix, the market MMM, where everyone marries their like, the index should be reached its maximum at that market. So it's going to be the value of the index for that market is not smaller than the value of the index for any other market. So these are the two conditions that we require that a measure of positiveness should satisfy. As I said, already highlighted, this is not a complete characterization, which means that different indices could satisfy these properties and actually give different results in terms of comparing two markets. So two indexes that satisfy these conditions could suggest that increasing positive associative matching in between when you compare two markets, while another index that also satisfies these conditions could suggest a decrease. Okay, I will then discuss as well how, whether we can actually improve on this. Hans, Martin, do interrupt me as I go along if there are questions that come in and that I should address.
There's actually one right here.
I can't hear.
Yeah, I will repeat, no worries. So whether you can do anything about remap as they are getting more important.
Whether I can do anything about remarriage. No, that's the short answer for the time being. This is actually a super interesting and important question, I think. And that's something that we try to address in a much more heavy model and sort of structural approach. I think with this particular analysis is mostly interesting and important for first marriages, and not as much for when you think about divorce and remarriage and so on. It's going to be a very static approach, and so I'm afraid this is not going to be the sort of main my way of addressing that. Having said so, the fact that across markets, divorce changes or divorce probabilities change and change differentially depending on your characteristics. And remarriage probabilities also change again differentially across your characteristics, will mean that, for as long as agents are aware of that, they will bring that knowledge forward and they will slot it in and consider it when they value their options in the marriage market for the first marriage. And so these remarriages and divorce is going to be reflected in the values that individuals assign to marriage to start with. So to some extent, indirectly, it's considered here, but this approach, I don't think is the correct one to then look at remarriages and the values of remarriage. But again, that's actually something that we could think a little bit more about.
There's a follow-up.
Yes, the follow-up question is: if people are personalization or contact, for example, 9 months later, we know whether marriage or not. So it could be the case that some people are married and then the fact.
So I think the short version of the question is: do you observe whether it's a first or remarriage in the data that you're using?
No, or better. I'll tell you a little bit more about the data in a few slides once I'm done with the theory. The data is going to be a static cross-section sort of data. I'm going to use a CPS. And we do observe marital status, and in the marital status we know whether people divorced, but we don't know whether they in their whether their marriages are the first one or the future marriages, later marriages. It's partly why we consider this age group, because it's an age group that is less likely to be in their second marriages, but that actually could have changed from one cohort to the other. It is not the same for the UK data. For the UK data, we do have more information about whether there's the marriages are the first or second.
I think that answer was great.
Okay. So let me then continue. So I've now characterized, what an index should satisfy, or the condition that an index should satisfy for us to, at least consider it. But I also told you that, the fact that they satisfy, that an index satisfies these criteria doesn't necessarily mean that the answer is, unequivocal and unambiguous. So to now progress on that and be able to derive an index that we want to use, I'm going to consider measuring assortativeness in a marriage market where I assume transferable utility. Just so that for those of you who don't know what transferable utility might mean, it means that spouses essentially agree on the marginal value of at least one good. And so they have essentially a currency that they can use to trade utilities, that they can use to transfer utility from one to the other, because they value that currency, that good, equally. And so what will happen is that in a transferable utility framework, the value of a marriage can actually be characterized by the sum of the utilities of both spouses, which is not the case of what happens when the transferable utility is not the case. It doesn't happen. Well, it's not assumed. So using this transferable utility setting, we will define an index of assortativeness that is, as I'll tell you, is going to be linked to the structure of the sorting problem. So what we want is that that measure will allow us to study whether changes in the marital sorting matrix are then driven by the changes in the gains from marrying, or the changes, so the structural changes in the value of marrying, or changes in the composition of the market. And we start by defining this population of men, which are indexed by I, who have observed characteristics xi, and of women, j, who have observed characteristics yj. And so essentially I'm going to assume that these x and y are desirable characteristics in the marriage market. So the value that Mr. I, for Mr. I, of marrying this Mrs. J is going to be this U function of his own characteristic xi and yj, and is going to be increasing in yj. While for Mrs. J, the value I'm going to denote it as V of xi yj, and this V is going to be increasing in the characteristics of his spouse xi. And as I told you, under transferable utility, the economic value of this match between I and j is going to be just the sum of the two values for Mr. I and Mr. J and Mrs. J, and I denote that by S of xi yj. So if we formalize, or if we set the value of singlehood to 0, then S becomes the surplus created by the match, that is the value, the additional value that the marriage between these two individuals creates, in addition to the value that they have of remaining single. And so that's how we are going to interpret it, this as a surplus. Okay, let me now introduce a definition that of supermodularity. So we say that a two-dimensional surplus function is supermodular if this condition holds. That is, the sum of the surplus that is obtained from like marrying like, so in the two cells, say for, sorry, actually back off. Let me consider again 2 by 2 matrix or two cases. Mr. X and Mr. X prime and Miss Y and Y prime, where, you know, just to set ideas, I have X being smaller than X prime and Y being smaller than Y prime. And so we've got essentially again a 2x2 matrix in X and Y. And I say that this function, the surplus function S of xy is supermodular when the sum of the surplus between that is obtained from like marrying like, so S xy and S x prime y prime, minus the sum of the more unequal marriages, X marrying Y prime and X prime marrying Y, is positive. What this implies is that what it means is that the gain from marrying up, essentially, is increasing with your own characteristic. That's what is shown by rearranging this expression as I do in the second equation over there. So when Mr. X prime, who is has a higher characteristic than Mr. X or Mr. X, moves from marrying Y to marrying Y prime, so moves up in the marriage market, the surplus increases by more than if it was instead Mr. X, who has a lower characteristic than Mr. X prime, moving from marrying Y to marrying Y prime. Okay, so in other words, there is complementarity between the characteristics of the spouses. The surplus of marrying up is larger the bigger your own attribute is. What this complementarity creates is the incentive to sort positively in marriage. Okay, so this suggests index of assortativeness that is essentially the supermodular core of a 2x2 matrix. So let's move backwards back to the matching matrix between college graduates and high school graduates. And now I represent here the surplus matrix, which is parallel to that sorting matrix, which in each cell contains the surplus that is obtained from each possible marriage of combination of spouses' characteristics. And the supermodular core of this matrix is going to be simply the sum of the main diagonal minus the sum of the off-diagonal terms. So essentially exactly the same measure that I had in the previous slides. And a positive supermodular core means complementarity between X and Y, as I explained before, in generating value from marriage. And it essentially implies a tendency for positive associative matching. And the more positive the core, the stronger this incentive, because the more it's gained in terms of total surplus by marrying one's likes. Now, note one thing, that the value of singlehood does not matter for this measure. It essentially cancels out on these subtractions. What does matter is how the gains from marrying up change with one's characteristics. The value of singlehood in turn will matter for determining whether to get married at all. And we will see as well for determining the actual values that each spouse is going to get from marriage. Okay, so why this is interesting, it is also very impractical because we do not observe the value that individuals assign to marrying different spouses. And so one possibility to make progress is going to be to use the Schussiau framework, which allows us to link sorting patterns to the value of marrying different spouses, and as you know, through that is going to offer a structural interpretation of assortativeness. Essentially, what it is going to allow us to do is to map the sorting patterns that we do observe, so you know, observed patterns in marriage, and onto the gains from marriage. And because we then know the gains from marriage, we will be able to think about changes in sorting patterns and translating them into changes in the gains from marriage, and thus revealing how, marrying your like versus marrying your not as like is changing over time, and therefore giving us a structural interpretation for why marital patterns may have changed. It is by comparing essentially the matched surplus in two different markets, we will be able to assert in which market it is stronger, there is stronger complementarity between the characteristics of the spouses. And so effectively, we are going to be able to determine how the two markets compare in terms of assortativeness or tendency for assortativeness. The one other aspect of this framework is that it's going to allow us to consider both observed and unobserved characteristics of the spouses, even though in a quite stylized way. Okay, so let me tell you a little bit about this Schussau framework. We consider it's a marriage market without frictions, and again under transferable utility. The sharing of gains from marriage is what's going to clear the marriage market. And under these prices, which are determined by which are essentially how the individuals share the surplus, Mr. I is going to choose who to marry and whether to marry at all by maximizing his own utility. His price is the maximum utility that he can obtain from marriage. I'm going to call it this small u underscore I. So essentially that's how much he gets from the surplus from marrying, his best choice. If he marries Miss J, who is going to have a value small v j, then they are going to create a surplus, which is Sij, which is essentially the sum of what each obtains in the market. So u underscore I and v underscore j. Okay, and the sharing rule is essentially determined by the small u and small v. Okay. So let me tell you about Schussau assumptions. I assume that there are many men and many women participating in the market, but there are not very many types, observed types. So for instance, there are education, there are 4 types on each side of the market. You can easily expand it for many more, but they always need to be finite. And I'm going to formalize the surplus so that S from the match between Mr. I and Mrs. J as a sum of 2 components, that Z capital I, capital J. So a part essentially that depends only on the types of the individuals, the groups they belong to, plus a gamma, which depends on the individuals themselves. Okay, so that Z essentially only depends on the observed characteristics, so on the types, the groups where we allocate them to, education in our case. The gamma is going to depend on individuals themselves. And I'm going to call the Z the economic value of the match, and the gamma is going to be related to the unobserved preferences that individuals have for each other. I further assume that gamma, which is the value, unobserved value of marriage, is going to be decomposed in 2 parts. A sum of a term for Mr. I, which depends on the type of spouse that he marries to, which is of type capital J, and a preference of Mrs. J for the type of husband that she gets, which is of type I. Okay, so you notice here that these preferences are not for specific individuals, are for types. So Miss I may like to marry someone who is a college graduate. Sorry, Mr. I may like to marry a woman who is a college graduate more than a high school graduate in terms of his unobserved components. They vary across individuals in the same group, but these are preferences for groups and not for individuals. So they are not love, essentially, and this is a constraint. I'm also going to assume that these shocks are extreme value distributed. But this can be relaxed, actually. So under these conditions, I can establish a key result, which is that there are a set of numbers, capital U, ij. Notice that it's the indexes I and j are capital, so they refer to groups, not to individuals, and v, ij, such that economic value of marriage, which is the z, is the sum of the two values. And this is true for all groups I and j in the population. And these numbers are such that for matched pairs in equilibrium, I can define the value that Mr. I gets from marrying, so from participating in the marriage market, which is the small ui, as the sum of that, economic value of marrying of someone in group I marrying someone in group J, uij, so the economic value for the man, plus his own preferences for marrying someone in group J. And on the other side of the market, for Miss J, the value that she has from participating in the marriage market is going to be, again, that aggregate value of someone in her group marrying someone in group I, plus her idiosyncratic value from marrying someone in group I. Okay, so this means what? This means that Mr. I is only going to marry someone in group J if what he gets from marrying that person in group J is larger or not smaller than what he gets from marrying someone in any other group K. Okay. And the same thing, we could, write exactly the similar expression for Miss J. So a woman J is going to choose someone in group I only if she gets more from marrying someone in that group than from marrying someone in any other group. But so what this then implies is that this set of expressions are essentially the set of expressions that underlie a multinomial logit, given the extreme value distribution assumption that we made on the unobserved components. And we can relate the probability of the conditional probability of marrying of someone in group I marrying someone in group J as the analytical expression for the probabilities given by in a multinomial logit, which is written here. And likewise, we can relate the conditional probability of someone in group J marrying someone in group I as a probability given by the multinomial logit. What is, yes?
Question, the difference between U and V. So capital U and capital V. Is that men and women?
Yeah, so U is always for men and V is always for women. Capital U is the economic value of someone in group I, say college graduates, marrying someone in group J for men, say a high school graduate woman. Okay, and capital V is going to, the value that the woman in high school graduate is going to get from marrying a college graduate man. I, yeah. So this is the economic value. Her own utility or value from marrying that man in group I is going to be the small v. It's going to be the sum of the economic value that everyone in her group gets from marrying someone in group I, plus her own idiosyncratic valuation of men in group I. Okay, is this clear?
I would think so, yes.
Okay, so I think, here to notice is that these expressions at the bottom are very convenient because they allow us to go from the probabilities that we observe, because we see the matching patterns, the sorting matrix, to the valuations of marrying someone in different groups. And so from here, we will be able to identify how different individuals marry, value marrying someone in different groups. Okay. It's you know, again, I note that the unobserved preferences should be interpreted as unobserved preferences of a man, say unobserved preference here epsilon ij, should be interpreted as the unobserved preferences of a man I for a group J woman, not for a specific woman, but for a woman in a specific group. So it's not love. It's preferences for a given level of education. Okay. The thing is that, you know, in this setting it will be very difficult to have love, because what it would imply is that nobody would remain single, which is, you know, against empirical evidence. Okay. So let me, any further questions here?
Maybe I missed one on the way. That was still on your model. There was one why you're looking at the differences rather than the ratios of the off diagonal to the diagonal elements.
Well, why I'm here, this is related to the definition of, you know, how you establish supermodularity and what supermodularity means. When you translate that into creating an index, you'll see that actually it's going to be the indices that it reflects. But, you know, we are relating to the theory here, and in the theory, you can characterize complementarities between types, you know, using this specific formula, which is essentially, you will see the second derivative of a function if you were sort of to translate it into continuous setting, essentially, where instead of types, you will have a continuous distribution of the x's and the y's. And it comes from the theory. Yeah.
A question which I'll need to read. Would this model with transferable utility and no search costs satisfy stability in matches only? That is, the surplus of two marriages ij and I prime j prime to be greater or equal than the surplus of marriages I j prime and I prime j.
Yeah, actually, okay. So yes, these models satisfy stability. So there is a big literature on this type of models, in particular because, you know, obviously they are the big drawback from this model is that it's a very stylized model, which is, you know, which uses very strong restrictions and assumptions that we may want to relax. But the big advantage is that it's a very well behaved model, and so yes, we have used it in various instances, and in particular, you know, coupling it with a life cycle model, both before marriage investments and after marriage decisions of, you know, labor supply and so on, and you can prove that the outcomes of the marriage market are stable. Okay.
Moves on to the specification of a semi-parametric estimator, but let's maybe postpone that till we get to estimation. By the way, you have about a bit less than half an hour left.
Yes. Okay. So let me then move a little bit faster here. Okay. So I want now to define index of associativeness, which I'm going to call the separable extreme value index. Which is going to come, you know, directly from the, you know, definition of the Schuss-Jahr model and the super modular core sort of structural index that I defined. So I have the P's and the Q's, the probabilities that I marries J and J marries I are observed. And you know, the first probability, the P's are that a man in group I marries a woman in group J, and you know, which can include zeros for not marrying, so a group zero. And the second is the same for women. So the Q's are the probability that a woman in group J marries a man in group I. So in our example of college and high school matching probabilities, the probability that a college graduate marries a college graduate, so a college graduate man marries a college graduate woman, is given, or can be written as n, so which is r in the matrix, if you remember, can be written as the number of men who are college graduates times the probability that a college graduate man marries a college graduate woman, which is this PCC that I defined before. And it's going to be the same as m, which is the probability, or the number of women who are college graduates times the probability that a college graduate woman marries a college graduate man, which is this QCC. Okay. So if I now apply the formula that I had before for the multinomial logit to recover this use, I can write the supermodular core, which is my measure, my index of assortativeness, which is structural, which relates to the values of marriage, which is this SM, if you remember, just written here again for you, for us to be reminded, can be actually then written as a function of the sorting matrix. This is easy to show. We do that in the paper. So it's that index of assortativeness is essentially going to be the empirical counterpart, so relating to the probabilities, the matching marriage, the matching matrices, is going to be given by that expression, the logarithm of the ratio of the diagonal elements divided by the product of the off diagonal elements. Okay, so which somehow goes to the intuition of the person who asks about it being a product instead of or a ratio instead of a difference. So that's sorry. So that's what we obtain from the identification of the values of marrying that we got before. Okay, so essentially what we were able to do was to transform the structural index, which is not very useful because it depends on things that we do not observe, onto things that we observe. So we are able to see how it varies. Now, by the way, this, there's a huge structure behind it so that you can interpret it, but this is a non-parametric estimator. This is simply, the ratio of the diagonal elements divided by the ratio of the off-diagonal elements. The more you have on the diagonal, the bigger this ratio is going to be. So, this is totally non-parametric, but it does not have an interpretation if we don't have the structure behind it. Okay.
Another question, whether the sex ratio affects the results.
Sorry, say again.
Whether the sex ratio between men and women would affect the results.
All right. So no, not in terms of assortativeness, in the sense that the sex ratio affects the probability of marrying. So the long side of the market essentially is going to have more single individuals than the short side of the market. And what it would mean is that when we want to identify the values are going to change. In terms of these condition on marriage, in terms of these indices, they are not going to change. These indices, are not going to be dependent on how many individuals do not marry, essentially. They only depend on as you see actually from the definition, they will only depend on the sorting matrix that is conditional on marriage. Okay, so that's for assessing assortativeness, conditional on marriage. Once you want to include the singles, then sure, for the relative value of marrying vis-a-vis remaining single, these are going to be affected by the ratio of men and women. As actually we take that into account when we do the application. Okay, so let me then, just formalizing, saying that we say that a matrix, it's again conditional on marriage, M and R is going to be more assortative than another matrix, another market M prime, N prime, R prime, if the index that we just defined in the first table, for the first table, is larger or equal than the index that we defined for the second table. And as you see, you know, if we have that structure behind us, then this index of assortativeness is going to be directly related to the supermodularity of the deterministic component of the value of marriages of the surplus matrix, essentially because the separability that we impose implies that the stochastic part of the value of marriages essentially has no role here in determining assortativeness and changes in assortativeness or the value of this index. Okay, so let me just tell you about the properties of this index. The two minimal conditions that we impose, these are both satisfied by this index. It is increasing in R when M and N are the same, and the index evaluated at the sort of perfect sorting matrix MMM is going to be plus infinity, so obviously nothing can be bigger than that. There are other properties of this index too. In the random matching case, where the probability of college-college marriages is equal to M times N, the index is going to assume the value 0. And so positive assortative matching is detected by the index being positive. And we can also calculate the index based on we can calculate the index based on sorting metrics that are conditional on marriage, as you've seen. So in other words, we do not need to know the probabilities of not marrying to calculate these indices. But as I told you when responding to the question, to fully recover the structural value of marriage, we will need to know the outside option. We will need to know the all sorting information, and therefore how many individuals remain single, to have this information. What we do identify here when we use conditional matrices is instead the relative value of marrying, say, Y prime compared to marrying Y, but not the absolute value of marrying Y prime or Y relative to being single. Okay, so moving a little bit quicker than I was hoping, but we have seen that, you know, under these very strong conditions, which depend on the extreme value distribution and separability, we can define this index. In particular, the distributional assumption is not testable and not particularly appealing. We don't need it, actually. The same results that we have derived apply to other assumptions regarding the distribution of the unobserved component of preferences. But we do need separability of the unobserved component of preferences to be able to derive this type of index with this interpretation. There are two caveats. Comparing tables actually does not require the assumption that the underlying distribution of stochastic preferences is the same. Comparing tables does require the assumption that the underlying distribution of stochastic preferences is the same in both markets. So it's not only that we need a specific assumption to be able to interpret the index on a specific assumption on the distribution of the error component, but we also need to assume that the same distribution holds in both markets. The other caveat is that the ordering of the table, even though we don't need the specific extreme value distribution, other distributions, we will be able to derive a similar index for other distributions. The ordering of the tables unfortunately does or may vary with the underlying distribution of the error component that we assume. So is there a way of relaxing these assumptions? So the question really is whether we can generalize our results to any distribution of unobserved preferences for different spouses. So, addressing these two caveats. We can generalize these results, but unfortunately not in a simple way, and and not in a way that can be described by a single index. Instead, what we prove is that if two matching matrices, say M and R and M prime and prime R prime, are such that the proportion of individuals in each diagonal term in the first table is larger than the corresponding proportion in the second table within each row and column, then the first table is going to be unambiguously more assortative than the second, independently of the assumption that you make, or independently of the distribution of the unobserved components in the value of marrying. So this set of assumptions, or this set of conditions that need to be that need to hold for us to unambiguously say that one matrix is more assortative than another, are described here. Okay, and what you can see is that in many cases, because it's not in one index, there are many conditions. In many cases, it won't be possible to say which market is unambiguously more assortative than a different market. Okay. Now let me skip this, which is some discussion of other indices of assortativeness that exist in the literature, and move quickly to show you some results of, in particular, the generalized, our generalized approach, and of the SEV index. So again, I'm using data from the CPS, the March wave, from 1962 to 2019. Just very briefly, this is a household survey. I guess you probably, you might not know actually more about this survey than I do, but it essentially records information for all adult members of the household, and, critical for us, the relationship between them. The survey contains very detailed demographic information and socioeconomic information. It includes, marital status, the age and sex of each individual, their educational levels, and their earned income. We formed the 4 educational groups that I told you about, and what we would do is to form or to construct cohorts, 10-year cohorts, born from the 30s up to the 70s, and compare the metrics. The matching patterns of these cohorts to say something about how they changed. Just to define what marriage means, I told you that I'm going to look at 35 to 44-year-olds and marriage patterns in there. I'm going to consider as singles everyone who is a widow, divorced, or never married. That's because I can't see, who their partner or the characteristics of their former partner. And I could as well have excluded. In this case, I didn't. It doesn't actually make very much of a difference for the results we have, in particular because these are not, the widows and the divorced are not a very large proportion of the population for these age groups. And for couples, so I told you that I'm considering this 35 to 44 sort of window, of age. For couples, I'm considering families where at least one of the spouses is in this age range. So I allow for the other spouse to be either a little bit younger or older. Okay, so let me just show you how marital rates evolved over time. So first addressing the issue of singlehood, you can see that the proportion of those who marry has dropped very dramatically, particularly among the least educated, which are they're represented in solid blue. The marital rates of college graduates, which is similar to those of the other groups in the early 60s, when the data starts is now much higher than for the other groups, and by almost 20% in particular when you compare with college graduates. So it remained much more stable over the period than the marital rates for lower educated individuals, which, you know, immediately suggests that actually the value of marriage has dropped more at the bottom of the distribution of education than it did at the top. Interrupt me if you've got a question. I know I'm going a little bit fast now, but I just wanted to show you the results, but to interrupt. So what happened to the sorting patterns and of those who married? Here we consider the two extreme cohorts, those born in the 30s and the 70s. Just, you know, there is a sort of a evolution from the 30s to the 70s, but we are going to show the results on the two extremes. What we see in these sorting matrices, so this is now conditional on marriage, is that a high proportion of marriages were concentrated among the least educated and the older, for the oldest cohort. So for the, on the left-hand side table, and that shifted towards the more educated among the youngest cohort, which sort of reflects the single rights that we saw before. So for instance, the proportion of couples where both spouses have no qualifications declined from 18.4% to 4.5% here and here, while the proportion of where both spouses and college graduates increased from 7.8 to 28.4. These sum to 100, essentially, all of them. What we also see is that there is a strong concentration in the main diagonal. That's in both cases, in both periods, and very little mass, in particular at the very end, sort of the most unequal cells, the most unequal marriages. And it's also interesting that the proportion marrying outside their education class changed differently for men and women. So in particular, women are now more likely to marry down. So we've got more mass here on the top half of the matrix of diagonal than at the bottom, while it used to be the opposite in the 30s. Okay, so I'm going to look at these 2x2 subtables to characterize how sorting has changed in the various parts of the distribution of marriages. So I'm going to consider all 2x2 submatrices, even when the characteristics of the individuals are not adjacent, so that when they are not sort of in the adjacent positions in the matrix. So this tells us about local changes in assortativeness. I'm also going to look at merge tables, that is marrying your like versus marrying anyone else. So marrying a college graduate marrying a college graduate versus marrying anyone who is not a college graduate, so with lower levels of education, which will give us a more aggregate view, complete view of changes in assortativeness. So essentially, what measures am I going to look at? I've got this 4x4 sorting matrix for the 4 educational groups. I'm going to construct all these 2x2 submatrices, okay, which includes comparing, you know, high school dropouts and high school graduates, high school graduates and some college, but also high school graduates, high school dropouts and high school and some college, and high school dropouts and college degrees. So I've got all combinations. And then I'm also going to construct the merged matrices, which include, you know, college marrying together, vis-a-vis or versus marrying someone from any other educational group, and in the other position in the main diagonal is any other educational group marrying any other educational group. And then I'm going to test whether the changes that I observe, so the difference between the 30s and the 70s, are statistically significant using a multiple test step-down procedure developed by Romano and Wolf. So I correct for the multiplicity. Okay, first of all, let me tell you what we can conclude when we look at the generalized conditions. So what evidence do we have of unambiguous changes in assortativeness when we compare the two the two cohorts. And what I can see, these are the various measures that I use, is absolutely nothing. So there is no one instance, one single comparison where these generalized conditions provide any information at all. What is clear from these tables is that, you know, unambiguous changes in assortative are really uncommon and very hard to establish. By the way, for the UK, there was one single group where we could establish an increase in assortativeness when we use, I think, 5 categories for education. So unambiguously establishing changes in assortativeness is actually really very difficult. Okay, but let's, you know, then impose a bit of structure and calculate what we can say using the extremely valued assumption on the distribution of the unobserved components. So here, again, I'm comparing the 70s with the 30s. A positive difference means an increase in assortativeness. What we see is, you know, generalized when we're looking particularly locally, a statistically significant increase in assortativeness on most margins, or in all margins when we look locally, actually. Once the merge tables are added, there is a single group, which is this of high school graduates, for which we see a drop in assortativeness. But otherwise, we see always a positive increase in assortativeness. Interestingly, actually, the other measures that I didn't tell you about actually offer very similar results. This is actually reassuring because they are going to be based, they don't have a structural interpretation, but they are going to be based on different assumptions. And we can see that the conclusions that they rise to are not that different from what we conclude using these arguably very strong assumptions to be able to interpret SEV structurally. Okay, how much time do I have, Hans Martin?
5 minutes.
5 minutes. Can I then take this opportunity to show you, given that we have this structural interpretation, the big advantage of it is that we can do some counterfactual simulations and see, in which way would we have predicted sorting to happen if the valuation of marriage had not changed from what it used to be in the 30s. So just like I can use the matching patterns to recover the structural metrics of marital surplus to study assortativeness in a way that is interpretable, we can also do the reverse exercise. And now that we have the sorting patterns, now that we have the valuations, what sorting patterns would be implied by the valuation, say, of the 30s, if the individuals would have acquired education to the extent that they did in the 70s. So if I change the distribution of education of underlying traits in marriage, how would the preferences of the 30s, what implications would the preferences of the 30s have on the sorting patterns that we would observe? So to be clear, we say that two markets are equally assortative if the sorting that we see on both of them is generated by the same matrix of marital surplus. It doesn't mean that the sorting matrices are equal. They are not necessarily. The sorting matrices may be different because the underlying distribution of traits is different. But if the surplus, if the values of the valuations of marriage are the same, then they are just as assorted. So what we do here, it would be to use the SEV index to determine the counterfactual sorting by emulating the assortativeness of the market of the 70s, of the market of the 30s, and the marginals of the market of the 70s. So first, let me look at singlehood. So I superimpose these preferences of the 30s on the population of the 70s, which is more educated. And here, this table shows what the implied singlehood rates would be by education and compare them with their actual values. So the actual values are in the two columns on the left, and then I've got the counterfactual singlehood rates on the right. And what you see is really dramatic differences between the two columns on the left and the actual values of the right. Marital rates essentially have gone up very considerably, and education alone cannot explain this when we compare. So have gone up in the counterfactual when we compare the two. So this happened actually for all educational groups, as you see here, as compared, for instance, with here, except for this one group, which is that of highly educated women, for whom the rates actually haven't changed as much. So what you see is that, if in the 30s preferences, individuals have much higher preferences for marrying than they have in the 70s cohorts as it is, which is reflected in the fact that the 70s cohort is much less likely to marry than they would be if their preferences would have remained unchanged from what they were in the 30s. Okay. Now, this, for instance, could be, a response to people in the 70s having much more protection while single when they are adults than people who were born in the 30s. Okay, so conditional on marriage, the sorting patterns are also different. The main difference here, and that is clear, is that educated men are marrying down less than they would if they had the preferences of the 30s, while to compensate, low educated women are also marrying less than they would under the old preferences. So you can see, in other words, that the sorting patterns under the 30s preferences show much less concentration of marriages above the male diagonal, where women are more educated than their male spouses. So it's sort of the modern type of couples, relative to those observed in the 70s birth cohorts. And they also reflect more concentration below the male diagonal, where men are more educated, which is, preferences towards traditional sort of marriages. So essentially, this shows how changes in the value of marrying different spouses led to a drop in the frequency of, the classical households, where husband is more educated than the wife, and an increase in the modern households, where the wife is more educated than the husband. Notice that the distribution of education is the same on both tables here, on the 70s table that we observe and on the counterfactual table that we observe. And so it's not the fact that women, these differences here are not driven by the fact that women are more educated now than they used to be. They are in both tables. These are driven by the fact that the preferences are such that women now, the preferences, the preferences for marriage are such that marriages between more educated women with lower educated men are more valuable now than they were back then in the 30s.
I think you should slowly come to an end, please.
And I am. So, this is just to give you a overall overview of what we've done. We have, essentially looked into how to define PAM and how to define changes in PAM, and we've established that, the second is actually quite hard. It can't be done so simply in ways that are completely unambiguous, or when we do that, not much is actually can be concluded. What we do is to propose a new index, which is based on quite strong assumptions, but that has the advantage of explicitly linking the sorting patterns that we see to the underlying forces that drive these patterns. The index is non-parametric. It doesn't require this interpretation to be a valid index of assortativeness, but it does, with the underlying assumptions, give you information about the structure of the problem. And the advantage of doing this is that we can then draw conclusions about how the preferences changed, and we can run counterfactual analysis of what they would have been if preferences had not changed or would be different. And I can conclude here.
Great, thank you. You only heard half of the big applause because I managed to mute the microphone briefly. But I think we all enjoyed it a lot. Interesting, for me at least. There's one more question. Can you say something about how this framework might try to accommodate something like search costs or consideration sets? So issues like geographical distribution of where types live or work seem like they might bias estimates of surplus and sorting. If I may rephrase, sort of, I had a related question in general, how you think about search frictions. So maybe surplus didn't change at all, but meeting possibilities change because you go to college together or jobs are more associative. And these days, of course, all the online apps, which have the, I guess, associative mating more or less built in, might even stronger reinforce that, whom you meet in the first.
Yeah, that's a tough question. This framework really, so as I say, the framework doesn't require no frictions, but the interpretation does. And so and really, you know, it's for us to be able to give this structural interpretation, we do need we will need to, you know, essentially derive a different set of conditions or a different index if we were to consider the, you know, frictions in the model. It's just, you know, not the framework that we are considering. Having said so, different markets, different geographies, etc., you know, they can actually be incorporated as different markets, right? And there's different places where matching occurs, and where you know, and where you look at assortativeness along the dimensions that you want to look at, and so you can analyze them. And, you know, and essentially look to or for differences in assortative patterns across these markets, and there eventually, you know, if you build up on why the valuations may be different, then arise to some conclusions about, you know, what these, you know, what sort of issues may be underlying these various markets and the patterns that you observe. So that's one way of, you know, looking at different geographies, looking at different platforms for marriage, etc.
Excellent, thank you. Any more questions? No, so let's give Monica another hand.